This is the video for Lesson 17, Special Right Triangles. You're learning for April 5th and April 6th. Question of the day. I wanted you guys to rank these spells in order of importance. Which one would you want to do first if you could do all of these different things? From Geometry and Algebra 2, you learned about special right triangles. Remember, we have two types of special right triangles, a 30, 60, 90 triangle, which is created from dividing a rectangle in half, and a 45, 45, 90 triangle created by dividing a square in half. Based on those angles and proportionality, the sides will always have the same ratios. So in a 30, 60, 90 triangle, the side across from the 30-degree angle will always have a ratio of x. The side across from the 60 will be your middle length side and be at x root 3. And your hypotenuse will always be the longest across from the 90-degree angle at 2x. In the 45, 45, 90 triangle, again, it's a square cut in half. That means both side lengths are the same as direction of a square. The 90-degree angle is cut in half, creating that 45, 45, 90 triangle. If you were to use Pythagorean theorem and find the length of the hypotenuse, you would see that that's a root 2. Now, on the first one, I used an x. The second one, I used an a. Again, it doesn't really matter what variable I'm using. What's important is to look at those ratios. So let's start with the 45, 45, 90-degree triangle. Again, it's always going to have a ratio of a root 2. What I like to do is create a little table, and I go 45, 45, 90 triangle has a ratio of a root 2. Once I have that structure and that outline, it makes it easy to fill in the missing piece based on what you know. For this one, we know one of our sides is 5. That means a equals 5. And the hypotenuse would carry on that ratio of being a root 2. Since a is 5, it'd be 5 root 2. The harder part for students is when their hypotenuse is a whole number. So remember that ratio should be a root 2. But this time, instead of that hypotenuse having that root 2, it's just a whole number of 17. So I have to solve for a. So I set it up and say a root 2 equals 17. Divide by root 2 so I can isolate the a. Rationalize the denominator by multiplying by the square root of 2 over the square root of 2. And then I get the length of the sides to be 17 root 2 over 2. Same thing applies here for our 30, 60, 90 triangle. Again, the shortest side is always going to be x. The middle side is x root 3. The longest side, 2x. Again, I find it helpful to make a table. So I go 30, 60, 90 has a ratio of a root 3, 2a. So I figure out, what do I know? On this one, I know the length of the hypotenuse. Based on those ratios and proportions, that should be equal to 2a or 2x. So I set that equal. Solve for x. X equals 10. That means that is the side length across from my 30-degree angle. The remaining angle would be 60 degrees. This has to have the ratio of x root 3. Sorry, I'll use a root 3. Since a equals 10, this is going to be 10 root 3. Another way, again, using that chart, you could go 30, 60, 90 has a ratio of a root 3 to a. I fill in what I know. I solve for a. Find the missing sides. Again, that 3 by 3 table can be helpful. Way to organize your thoughts. Again, where we end up having a difficult time understanding is when the side across from the 60 degrees that should have a radical to it is a whole number. So for this example, the side across from 60 degrees is 12, when it should have that ratio of a root 3. So I set that up as an equation. A root 3 equals 12. Solve for a, divide both sides by root 3. Rationalize the denominator, reduce my fraction. So what that means is my a value is actually 4 root 3. So that would be across from the 30-degree angle. And then my longest side has that ratio of 2a. So I'm going to double that and get 8 root 3. Now I found all angles and all missing sides of that triangle. I'd like you guys to pause the video and try some on your own. After you've had time to process, let's check your answers. Again, I really like to set up the 3x3 table. 30, 60, 90 triangles have a ratio of a root 3, 2a. Again, that can be multiplied by making them really big or divided to make them small, but those ratios of sides will always be proportional if your angles are 30, 60, 90. So the first one, we had to do the calculation because a root 3 equaled 6. So we divided by root 3 and rationalized. That means a is going to equal 2 root 3. So 2a equals 4 root 3. The next one over, again, I set up my 3x3. 30, 60, 90 has a ratio of a root 3, 2a. I knew the side across from 30 was 8. So then across from 60 is going to be 8 root 3. Double that 8 and you get 16. Next one down, 45, 45, 90 has a ratio of a root 2. If 8 equals a, your other side is the same as a, and the 90-degree side is the hypotenuse at a root 2. The last example, again, I start with my 45, 45, 90 triangle in the form of a root 2. I know that a root 2 equals 14, so I set that up, and solve for a. I have to divide by root 2, rationalize, reduce the fraction, and you get a to be 7 root 2. Okay, that's the end of the lesson. At this point, you should be able to do the exit task for lesson 17 and WAMAP. That will be your last lesson before your quiz on either Thursday or Friday.